Okay, good evening, everyone. You're
Good
welcome to
evening.
another class today.
Good evening, ma. Thank you, ma.
Good evening, ma'am.
Yeah, good evening. Okay, I hope you have your questions because this will be the last class with you. After which I'm going to share general revision questions. Then we'll be expecting to see on the exam day. That's off camera though, because I know I will not be visible then. Okay.
Okay, ma'am.
Is the course rep available? Course rep is not available. Course rep is not available yet. So Abams.
Yet. Yes, ma'am.
Okay, he's not available. So you're going to be my co-host. Please make sure
Okay,
you
ma'am.
maintain the class and
Okay,
mute
ma'am.
yourself as well. Let's all be muted so we can have a smooth ride, please. Thank you for your cooperations. All right, so let's go. Today we're going to talk about benzene and aromatic compounds. Okay, whenever you're talking about benzene, you're actually talking about aromatic compound because the simplest of aromatic compounds is benzene. So whenever you're looking at aromatic compounds, you must see the basic skeleton of benzene. So if there is no benzene, there is no aromatic compound. Now, I want us not to mobile up aromatic compound with esters. Esters are compounds that have aroma, does not make them aromatic compounds. So aromatic compound are compounds that have basic moiety of benzene. Okay, so whenever you see a compound that has benzene, whether one benzene and any other compound, the compound is aromatic because of the presence of benzene. Okay, it's benzene that made it to be aromatic. Okay, give me 5 seconds. Let me connect my earpiece. Oh, I hope you can hear me. Let me know if I'm audible enough.
Yeah, we are hearing you clearly.
Okay, very well. Thank you. Okay, like I said, so when we're going, that's why we're talking about benzene and aromatic compound. Okay, the simplest formula of benzene is C6H6, right? Meaning it has equal number of carbon and hydrogen. Now, this benzene has 4 degrees of unsaturation, making it highly unsaturated. Okay, whereas other unsaturated hydrocarbon, you know alkanes, alkynes, and even the dienes. Dienes are compounds that have 2 functional groups, 2 unsaturation or 2 double bond, like buta-1,4-diene. So di is 2, in is double bond, 2 double bond. Okay. So all these compounds, because they are unsaturated, they undergo addition reaction. Typical reaction of unsaturated compounds are addition reaction. But benzene, being highly unsaturated, does not undergo addition reaction like any other unsaturated hydrocarbon. Now, if you look at example, we have ethylene, which is triple bond. Under bromination, which is addition reaction, is going to form bromoalkane, right? Now, but benzene cannot undergo addition reaction of bromination. Why? Benzene is the aromatic compound that whenever addition reaction occur in benzene, the ring will become saturated. Benzene will become cyclohexane. Now, because benzene wants to retain its name and its aromatic nature, it does not undergo addition reaction. So any reaction that will take away the uniqueness of highly unsaturated or unsaturation in benzene is highly avoided. So that is why benzene cannot undergo typical addition reaction, which is linked to all unsaturated hydrocarbons. Then the question is, what is the typical reactions of benzene? Benzene undergo electrophilic aromatic substitution reaction. Okay, now benzene does not react with bromine water except in the presence of an acid. This acid will help benzene to undergo substitution reaction either instead of addition reaction. I repeat, whenever benzene wants to brominate, remember bromination is an addition reaction. It's an example of halogenation we talked about when we are dealing with unsaturated hydrocarbon. So this benzene cannot undergo normal bromination reaction because it's going to form cyclo compound. In fact, it cannot even undergo it because whenever you it's not going to be benzene again, and it's going to lose some of the double bond, which can make it bromocyclohex something, either hex 1,4-diene or something. So it can no longer be benzene. So for benzene to undergo bromination, there's need for a catalyst called Lewis catalyst. This Lewis catalyst will activate benzene and make the reaction undergo substitution reaction. When you're talking about substitution, just like we talk about in alkane, we are saying that we are going to remove one hydrogen and replace with bromine. In that case, the bonds are not interrupted. So the reaction occurs only by removing one of the hydrogen and substituting whatever you want to do. If you are doing bromination or I want to do Friedecraft and other things you are going to look at. So the typical reactions of benzene is free radical substitution reaction. Free radical electrophilic aromatic substitution reaction. Electrophilic in the sense that with the presence of this acid, we are going to release an electrophile. Remember, electrophile is what? A positive ion. So the electrophile is going to replace another electrophile, which is hydrogen. So we are replacing electrophile. That's an electrophilic substitution reaction. So electrophile is replacing electrophile. Okay? And the electrophile that benzene is going to release is hydrogen. So another electrophile is going to replace it. We call it sim swap. So that's August Kekule proposed the reaction of benzene, saying that because the bonds in benzene are not real bonds, meaning that I cannot say that these bonds are here because the bonds are always alternating. Because the bonds are alternating, we cannot predict the exact position of the bond. And that is the reason why benzene cannot undergo addition reaction. Okay, but rather they can undergo substitution reaction called electrophilic aromatic. Remember, all the words are very important. They are electrophilic and they are aromatic. If you say electrophilic substitution reaction without putting aromatic, you failed it. So it must be electrophilic aromatic substitution reaction. So August Kekule is telling us that the bonds are not. Abam, you're not doing your work. Oh. You did not hear that somebody is making noise on the background.
No.
Please, I want us to have a smooth ride. So it's August. That's why August Kekule said that for us to represent benzene very well, because the bonds are always alternating, we can represent the bonds with a 2 rings. So he said the basic structure of benzene must be a resonance structure of 2 rings. because the bonds are always alternating. Okay, and that is why this is always represented by cyclohexane with a ring in the center, telling us that the bonds are moving around. Okay, so that is what brought about that particular structure where we have this, a ring connecting, telling us that there's always movement of pi electrons. These pi electrons are mobile, so they can resonate, alternate. Okay, so that's why we do this. Now, look at this question. What orbitals are used to form the indicated bonds? Then which of them is the shortest of them? Now, the shortest bond and the longest bond. If you look at if you're talking about the shortest bond, you're looking about the more the bonding, the more the pi electron, the shorter the bond. Then the longest bond are the bond that has saturated compound. So sigma bond is the longest bond, while the shortest bond are triple bond. Okay, so if you're looking at the shortest bond, look at the bond that had double bond. If there is no triple bond, it followed by double bond. So let's look at this. Now look at this bond. The first one is CP2, meaning I have two double bond, right? I know we know how to know about it. We are talking about the two carbons. The two carbons connected by this double bond are sp2 and sp2. Now, another carbon, we have sp2 and sp3.
Similar to solve today, pa.
Why are you people making noise?
Charles, I will remove you.
Sorry,
Charles,
ma.
Mute.
Now, whenever you're looking at the hybridization, I think I've said it in my first class, that you look at the carbon or the atoms that is connected by the bond you're looking at. If you look at where the arrows are showing in the middle of the bond, not the origin. So we're not looking at the hybridization of carbon, we're looking at the hybridization of bond. Hybridization of carbon is only one hybridization, while hybridization of bond is made up of two carbon or two atoms that are connected by the bond. If you look at the very first one where we have hydrogen, you can realize that the hybridization is sp2s. Then they'll tell you C means carbon. So that sp2 is hybridization for carbon, while S is hybridization for hydrogen. So in exam hall, you cannot see the C, you cannot see the H. So we're going to see the sp2H as hybridization because carbon is connected to hydrogen. So that's whenever you see hydrogen, you see S. Now the other one, we see sp2 and sp3, meaning that the carbon involved, C is carbon, the carbon involved is both sp3 and sp2. The one of sp3 is that carbon that is connected to saturated. But the one of sp2 is that connection where we have double bond, which is the benzene ring. Okay, so that is how to know hybridization. So if you're looking at the shortest bond are the bond that have double bond. So the sp2 are the shortest. So they are the shortest of the bond. But if we have sp3 is shorter than sp2. Okay, but the longest bond is saturated, that is sp3. Okay, we are talking about this. How do we name derivative of benzene? Derivative means compound that is being obtained from benzene. Now look at this first benzene. Benzene has a substituent called ethyl, so we call it ethyl benzene. The other one have a substituent called tertiary butyl, Why is it tertiary butyl? Because the carbon is all saturated. There is no hydrogen, making it tertiary. Why is it butyl? Because the total number of carbon is 4. So we call it tertiary butyl. So tertiary butyl benzene. Okay, this last one is chloro group. So chlorobenzene, if it's bromine, it will be bromobenzene. Okay. If you have questions, just hold on. When we finish the class, then we can take all questions. Just be noting your questions. I don't want to stop the flow. Then you can see that whenever we have there are compounds that have a generic name or a common name, despite they have substituent added to them. When we have methyl added to benzene, instead of calling it methyl benzene, it's better to be called toluene. Toluene is a common name. So if you see yourself in an exam hall and you see toluene, that is methylated benzene, don't call it methyl benzene. If you see option of toluene, toluene is most appropriate when compared with methyl benzene. Alternatively, when you have a compound that have hydroxy group attached to benzene, so you don't call it hydroxybenzene, either you call it phenol. Phenol is the most appropriate. So phenol name has taken priority over hydroxybenzene. In the same manner, when you have a compound that has carb amino group attached to benzene, instead of calling it aminobenzene, it's much more accurate to call it aniline. So aniline, phenol, and toluene have priority over their names, like calling in IUPAC name, like amino, hydroxyl, or methylbenzene. Okay, let's continue. Or should I take question? If you have, I can't hear. Somebody say I can't hear. Giwa Ibrahim said I can't hear. Is anybody saying I cannot hear? Folami, ask your question. So let me know if something I can.
I'm hearing now. I'm just hearing now.
Okay, you were
Good
not
evening,
hearing
ma'am.
before.
Yes, it's a network.
Okay.
Good evening, ma'am.
Good evening.
Ma, I'm lost. I'm not getting it.
Ah, where
No,
are you
is that I
lost?
don't know that you're too fast or something, but all when you got to the naming, I started understanding it a bit. But everything you said before naming, the nomenclature, I didn't get it, ma.
Like what? Oh, like what? Which of the slide were
When
you
you
not
were
getting?
explaining the CSP2, CSP3, shortest bond,
Okay.
longest bond, the electrochromic port, I
Okay.
was just lost. Thank you, ma.
You were just floating.
Yes,
Okay.
ma'am. I didn't get it.
Very uncle.
My question is, can't we call phenol benzol?
No, it's not benzol, I beg you. Phenol is not benzol. Okay, can we continue? Other than that, is there any other question? Because your hand is still off. Phenol is not benzol. Okay, so let's handle the question of okay, now this is hybridization. Hybridization will talk about mixing of atomic orbitals of the same energy level to form new hybrid orbital. Now, and we talk about that when you have saturated compound like single bond, the hybridization is sp3. When you have double bond, hybridization is sp2. When you have triple bond, the hybridization is sp. This is hybridization of carbon. Then when you have only hydrogen, the hybridization is S. Now, This is hybridization of carbon or hybridization of atom. But it's different from hybridization of bond. So if you ask about bond hybridization, look at the atoms that constitute that bond. Now, from this slide, you can see that I have C. Wherever you see C, C is talking about carbon. So what is interesting, well, my interest is the sp2 and S, meaning that my carbon here is sp2, while hydrogen is S. Wherever you see hydrogen, hydrogen is always S, is constantly S. So what changes is carbon. But because the arrow is not pointing on the point of carbon, it's pointing in between two carbons, talking about the bond. So I will ask myself, what are the nature of the atoms that constitute this bond? So from that one, I have the carbon that is connected to double bond, making it sp2. Then hydrogen is S. The second point, we see a carbon that is connected to sp2, which is in the aromatic ring, and saturated, which is sp3. So the bond is made up of sp2, sp3. So the last one on that compound is an arrow pointing in the middle of double bond, meaning that the carbon of this double bond is sp2, sp2. Then I said that this shortest bond is the bond that has multiple bonds. The higher the multiple bond in a compound, the shorter the bonds. So meaning that if I see triple bond is shorter than double bond. Double bond is shorter than single bond. Bringing it to life, if you're in a friendship is single bond. When you go, then you're still apart. But when you get married, that is double bond. The distance is shorter than when you are single, right? So when you start having children, the bond becomes shortest. So the more the bonding, the shorter the distance. So that is actually what this place is talking about. So whenever you see, assuming the arrow is pointed at the edge, it means I'm talking about the carbon or the atom, meaning that I'm going to have a single hybridization. But for a bond, the hybridization must be two because it takes two to tango. Did I answer your question? Have you understood
Yes, ma, it
it?
is clear. It is clear. Well understood.
All right, thank you. So I think we are talking about this. Benzoyl is not phenol. So let's continue now. We have a, remember this one is just when I have just one substituent, right? But I can have more than one substituent. Remember, benzene is made up of 6 hydrogen. So I can also replace all the hydrogens with electrophile. Okay. Now, this one I want to replace I want to add 2 substituents. Now, whenever I want to add 2 substituents, I have 3 predominant positions, which is auto position, meta position, and para positions. Now, auto position is when this substituent is at carbon number 1 and 2. We call it auto. Carbon number 1 and 3, meta. Carbon number 1 and 4, para. And remember, in benzene, we have 6 sides, carbons. But the 6 sides are giving us 3 different points because carbon 1 and carbon 6 are the same. Okay, 2 and 4 are the same. Then, meaning that 1, 2, 3, 4, 5, 6. 1, 2. 2 and 6 are the same. And 3 and 5 are the same. 2 and 6 are the same. 3 and 5 are the same. So that's why we have only 1 para, 2 auto, and 2 meta. So 1 and 6 is the same thing as 1 and 2. They are auto position. Okay. 1 and 3 is the same thing as 1 and 5. They are meta position. We only have 1, 1 and 4, which is para position. So meaning that if I have substituents at carbon number 5, I cannot call it 1, 5. I will call it 1, 2, because I'm going to follow the route that will give my substituent minimal number. And if I have a compound at position 1 and 5, I cannot call it 1 and 5. I'll call it 1 and 3, meaning my meta is facing the other side. So we have only 3, 1, 2, 1 and 2, 2, 1 and 3, and 1, 1 and 4. That's auto meta para positions. So when I have a compound like that, either I use the number to indicate the position. I can talk about 1, 2 dibromobenzene, or I'll say auto dibromobenzene, meaning that auto has been replaced with 1, 2. The same thing with other ones. Then auto, at times you can see auto as O represented, meta as M, and para as P. So they are the same thing, just for you to understand what they mean and the positions. Okay. Now, this is another. Remember, in the same one, we are talking about the same substituents occurring twice. But what if I have different substituents? What do I do? When I have different substituents, I will still talk about the auto meta para, but I'm going to name them by virtue of alphabetical order. Okay, so if I don't want to say auto bromochlorobenzene, okay, I will say 1 bromo 2 chlorobenzene, indicating the number of the substituent, but I have to name them giving priority to alphabetical order and indicating the position of the substituent. I have nitro, I have fluoro. Alphabetically, fluoro come before nitro, and the position is 1 and 3, which makes it meta. So either I talk about 3 fluoro nitrobenzene, or I'll talk about meta fluoro nitrobenzene. Okay, because nitrobenzene is already a name of a compound, right? So the same thing with others, as you can see on the slide. So whenever you have a compound that has 2 substituents that are different, indicate the position of these substituents and consider alphabetical order. Okay, I cannot say because my fluorine is at carbon number 3, I'll make it carbon number 1. No. Because it's alphabetical order, I cannot give it 1. I'll still give it 3. But I will indicate the position of the 3. But I'm going to name it first because of alphabetical order. So you don't because of alphabetical order and start naming, giving them the list number. You can only talk about giving the list number when there are more than 1 substituent. Now, if I have another substituent, I'll follow the route that will give me the minimal number. Now look at my nitro and look at my fluoro. I cannot go anti-clockwise because I'm going to have my nitro to be 1, 2, 3, 4, position number 5. While by my clockwise, I'm giving it position number 3. So these are the things you consider whenever you're naming a compound in aromatic system. The route, that clockwise or anti-clockwise, the one that will give it the minimal number on the ring. Okay, the same with others, as we can see on the slide.
Again, ma. Please repeat that again, ma.
I said that when I have a compound like this, I will check whether clockwise or anti-clockwise, the one that gives me the list number. This compound, if I say I should follow anti-clockwise, and my fluoro will be carbon number 5. 1, 2, 3, 4, 5. Yes. But if I go clockwise, I'm getting fluoro to be number 3. So I cannot say because it's fluoro, I'm going anti-clockwise, because it's going to give me the maximum number, which is not good. So whenever I want to name a compound, I have to follow the route that's going to give me the minimal sum on the ring. Clockwise or anti-clockwise. Nobody will tell you must follow clockwise. If my anti-clockwise is favoring me better, I will follow anti-clockwise. And if clockwise is better, I will follow. Okay, like we are going to see a situation where you have like 3 substituents. So I can explain this particular one better. Okay. Okay, this is another naming.
Sorry, ma'am. My hand is up.
Okay. Talk. Whenever I'm
Okay.
in a flow like this, I will not see your hand. So what you can only do to unmute and talk.
Okay, ma'am, please, I want to ask that whenever we are numbering a benzene ring, must we always start from where bromine is as our number 1? Can we start numbering, for example, where fluorine is as number 1, then go round, or must it always start from that hub?
No. Look at whenever you see a compound, you can see the starting point. The starting point is glaring now. You draw a structure, but by virtue of the structure you draw, you know where number 1 is. You cannot start from down to go up. You start from up to go down. So number 1 is beginning of the ring is number 1. Okay, look at the one by your side. You can see now, I cannot come to carbon number 3 or 2. Benzene ring is designed in the sense that 1 is distinct because the ring is a hexagonal. So I cannot come on the neck and give 1 while the head is standing. So my numbering is from the head. Except when there is no substituent on the head and I see my substituent on the arc, then I'll make the arc my number 1. It means that I have to rearrange my numbering. But as long as there is substituent on that first carbon, which is the head, it's automatically my number 1.
Thank you, ma'am.
So let's continue on this. I want to
Please,
name
ma'am.
this compound. Okay.
Excuse me, ma'am.
Go ahead.
Please, ma'am, this orthonitrophenol, can you name it according to the substituent, the individual substituent again, please, ma'am? The nitro and the
Your
phenol.
network, what is the problem?
Ma, I said, please, ma, this okay, it's not even ortho.
It's
The
methanized. No, it's
metal,
number 1,3.
I was seeing
Fluoro.
nitrophenol.
No, it's a
I was seeing
orthonitrophenol.
nitrophenol.
Is this third one, ma?
It's not this one.
Orthonitrophenol.
Okay.
This one, this orthonitrophenol. Can you please name it
Okay, what
according to the
happened?
substituent now? Like the numbering, the nitro group,
Now,
the
remember I
hydrogen.
said, you can call it 2-nitrophenol. 2-nitrophenol.
All right,
Remember
thank you.
I said that phenol is a general name. So this phenol is a compound already. Just like this one, you can see this one now is toluene. Okay, toluene is a common name. So so what I'm considering now is a substituent on the phenol. And the substituent is nitro. At what position? It's at position number 2. In that case, I am numbering anti-clockwise. I cannot go clockwise and give it position number 5. While I can go anti-clockwise, give it position number 2. Okay, now the same one, bromotoluene, because benzene that has methyl has a name called toluene. So what I'm considering now, the position of the substituent called bromine. If you look at it, you realize that the bromine is facing the methyl. When you number it, whether clockwise and anti-clockwise, position number 4. And remember we said that 4 has only 1. We have 2 ortho, we have 2 meta, and 1 para. So that's why we are talking about para-bromotoluene. Just like this one, orthonitrophenol. So I can call my para to be 4-bromotoluene, and I call my ortho my 2-nitrophenol. Taking.
Yes, ma'am. Thank you, ma'am.
Yes, ma.
Okay, let's continue. Now look at this naming now. Look at it very well. Now you can see now I have, this is benzene. I have ethyl, I have propyl, and I have chloro. Now if I have this compound, how do I name it? Number one, I have to look at the route that will give these three substituents the minimal sum. If I follow my anti-clockwise, I have position 1, I have position 4, I have position 6. But if I follow my clockwise, I have position 1, I have position 2, I have position 4. Meaning that my clockwise is shorter than my anti-clockwise. Now, even without going through it, you can realize that the way they move, 1 and 2, then 4, before we talk about 1 and 4 and 6. So meaning I'm going to have 1, I'm going to have 2, 4 as my best movement. But in my numbering, in my naming, I don't say because position number 1 is ethyl, I'll come and put ethyl before chloro. So I will still go and number alphabetically by saying 4 chloro, 1 ethyl, 2 propyl benzene. Irrespective of their position, I must make sure I name alphabetically. Is that clear?
Yes,
Look at this thing now. Now, this compound, by virtue of having amino attached to benzene, is called aniline. But this aniline has 2 chloro substituents. So if I follow my clockwise, I have chloro at position 1 and position 3. I have chloro position 5, 1, 2, 3, 4, 5, and 5, 3 and 5, making it 8. But if I go anti-clockwise, I have position 2 and 5, making it 7. So meaning that anti-clockwise pays better than clockwise in this. So that's why I have 2,5-dichloroaniline. So just make sure you look at the routes that give you the least sum. Even if it's only by 1, it goes a long way. Because in the exam hall, if it's an OBJ, you're going to get all the options. If you follow clockwise, you're going to get it. If you follow anti-clockwise, you're going to get it. So that's why we have to be very careful. Okay. Now, when I have benzene losing 1 hydrogen, it becomes a phenyl. That is why when I replace that hydrogen with hydroxy group, it becomes phenol. Okay. Now, my benzene can be a substituent called phenyl. So just like other alkyl substituents, we can also have a substituent called phenyl. Okay, look at this. I have benzene, okay, and I have another substituent, methylene, attached to it. When I have benzene and methylene attached to it, they become a substituent called benzyl. They become a substituent called benzyl. I'm going to remove some people, seriously, and I'm going to do that. And I cannot correct anybody again. So benzyl is a substituent. So benzyl is a substituent. So from there we have benzaldehyde. So we can also, like I said, as we have phenyl, we can have benzyl. Now look at this compound. This is a compound. Remember, this compound by virtue of the group is a toluene. So a toluene can also have another substituent added to it. So we are saying in essence is that benzene can stand on its own as a benzene, can stand as a substituent as a phenyl, can also have an extra additive, making it a complex substituent called a benzyl. So that's all we can say about benzene. This Jabi, I'm allowing Jabi to come in again. If anybody do anything, I'm going to put that person on waiting room, and the person will not come in. This is the last class. Please, let's have a smooth ride, I beg you. As you're entering, please mute yourself. Okay, let's do this IQ question. Which structure matches the given name, orthodichlorobenzene? What is the answer? Orthodichlorobenzene.
A.
Orthodichlorobenzene.
No. It's C. It's C.
Is C.
C.
So you have to be. It's because the answer is on the board. That's why you're telling me C. If the answer is not there, you not mistake I made. I would have removed the answer. Okay. Now we're talking about Hooke's rule. Oh, why are you guys behaving like this now? Am I not dealing with mature students? Why are you guys doing this? I don't want to get angry.
Ma, you can make someone a co.
I've made a co-host already. Abam. If Abam is not active, it should let me look for another person. I don't like my class being this. It affects me. Distraction affects me. Eh? Because if another distraction, because what I'll do, I'll just walk out of the class. You guys will go and read up. He said, what I'm giving is just like addition. It's not supposed to be about my syllable. So please don't disturb me a bit.
Please, guys, let us behave, please, so that we round up this class in good terms, please.
Now, what are the criteria that make a compound to be aromatic? We can talk about Hooke rule. A property or character of aromaticity or aromatic compound is number one, a compound, the molecule must be cyclic. Any compound that does not have a ring can never be aromatic. Okay. Number two, the compound must be planar. If it's cyclic and it's not planar, a plain compound is means that when I put it, I can see all the sides at the same time. If the compound is not planar, the compound can never be aromatic. Okay. Next one, the compound must be completely conjugated. A conjugated compound is a compound where single bond alternates double bond successively, meaning that they must follow a consistent pattern of single bond alternating double bond. When that pattern is interrupted by a double single bond, it becomes isolated. Okay, so we must have single bond alternating double bond in a successive manner, meaning it must be something that is consistent. Okay, if you look at the example we have here, the first one is fully conjugated. The second one is not fully conjugated because we have double, but the first two bonds are conjugated, and we have two space where there are no conjugation. So that's why making it not aromatic. The third one does not have a consistent conjugation because where you saw the arrow, no p orbital, there is no conjugation. So making it not aromatic. So for a compound to be aromatic, it must be cyclic, it must be planar, it must be fully conjugated or completely conjugated. Lastly, that compound must obey Hooke's rule. Hooke's rule says that Hooke's rule of 4n plus 2 pi electrons. 4n plus 2 pi electrons, meaning that when I calculate the number of bonds, it must comply with 4n plus 2 pi electron, where n is the number of ring. So if for benzene, my n is 1, and if I put it in the equation, 4 times 1 plus 2 pi electron, meaning 6 pi electrons. And look at the number of electrons in benzene, they are 6 pi, meaning that benzene is aromatic. Look at the next compound. This compound is cyclobutadiene. The cyclobutadiene is planar, is conjugated, but it does not obey 4n plus 2 pi electron. Because when we put my n, we are going to have what? 4 times 1 plus 2 is supposed to be 6 pi electron. But we only have 4 pi electrons, meaning it is not aromatic. So that's how to know aromatic compound using Hooke rule of 4n plus 2 pi electrons. Remember, planar, cyclic, completely conjugated, and obey Hooke's rule. That's the characteristics of what are the characters of aromatic compound. That's what you're expected to say. Okay, when my compound is O, that's no ring. Using my rule, the electron must be 2. You know that there's no aromatic compound without a ring, which means 0 is not an option. So when my ring is just 1 ring, the number of electrons expected is 6, and others as shown, just following 4n plus 2 pi electron system. Okay, we have a compound that is cyclic, planar, completely conjugated, and obeys 4n plus 2 pi electron rule as aromatic. When a compound is cyclic, planar, completely conjugated, and does not obey 4n plus 2 pi electron, we call it anti-aromatic. Non-aromatic are compounds that lack one or more of the following requirements. Okay, the compound is cyclic, planar, and not completely conjugated, is non-aromatic. So these are the 3 ways of considering aromatic compound: aromatic, anti-aromatic, or not aromatic. That's why we say cyclobutadiene is what? Anti-aromatic, because it does not obey the Hooke's rule. Okay, look at those compounds. Let's look at their differences. The first one is benzene. The second one is 135 hexatriene. Now, remember, the benzene is most stable because this compound is planar, okay, but it's not cyclic. 135 is not cyclic because the ring is not close. This is aliphatic. So that's why it can never be. But look at this one. This is less stable and anti-aromatic. Why? This one, number one, is anti-aromatic, we know. Because it's anti-aromatic, it is not very stable. Okay? This other one is not very stable because it's 1,3-butadiene. Remember, the more the conjugation, the more the stability. Less stable anti-aromatic compound, because number one, this one we cannot call it conjugated. Okay, now we have non-aromatic and we have both. Why are they non-aromatic? Number one of them is not completely conjugated. The other one is not cyclic. So this is also important for you to understand. Although questions cannot come in this form, just for you to understand it as a chemist. So look at all these polyaromatic hydrocarbons. Like I talk about these are, whenever you talk about polyaromatic hydrocarbons, these are compounds of benzene. And these are what we see when we are talking about PAH as poisonous. When you're talking about, that's the poison you see when you're eating your suya on open flame. That's the poison we encounter when you're eating roasted corn on open flame. That's the poison encountered when you're roasting your yam on open flame. And that is why people that use charcoal to cook often, they tend to have problem with eyesight because of the smoke, which is polyaromatic hydrocarbons. They are very poisonous. So that is what happens to smokers, that they are liable to die young, because that smoke is polyaromatic hydrocarbons. The darkness of the kitchen where they use charcoal to cook is what happens to the hearts of any smoker. I know that none of my students are smokers. So if you're one, please save your life and run. In fact, don't run, fly, because it's danger. So whenever you're looking at your heart, you're looking at that charcoal, that kitchen, that pot, the way that charcoal pot is, that's what happens to your heart. So
Into
that's
the
why
lungs,
even
to
if
the
you're
lungs.
eating your suya, don't indulge in them. That's why there is high level of kidney problem in this time, because of all the rubbish we are eating in the name of enjoyment. So let's apply caution. So these are polyaromatic hydrocarbons. You can see the first one is naphthalene. Well, we have 2 benzene joined. We have anthracene, 3 benzene. And then anthracene and phenanthrene, difference is arrangement of the 3 benzene. So far for your level, you can't go beyond 2, 3 benzene. Okay. If you look at this compound, you know that they are aromatic. Number one, they are all of them are completely conjugated. They are cyclic. Mawa, can we to enjoy suya? Is it safe that people enjoy the meat? If you want to enjoy your suya, if you have your oven, put it inside your electric oven. The problem with suya is open fire. And that's why if you look at the white, they only eat all those things when they're having festive periods. But Nigerians, we eat it every night. Every night you have to go to suya joints to enjoy, to kill your system slowly. But the white, whenever they're having a festive time, that's when there's something about degenerative. It's the lungs that can be black, not the heart. My dear, there's something about degenerative. When one organ is affected, it goes through other organs. Okay, when your lung is being affected by that, it also go through other organs. It can affect your kidney, it can affect your liver, it can affect your heart. Okay, because it's a degenerative thing. One affect the other. Just like you have a car and one thing is spoiled in the car. If you don't fix that thing that is affecting the car, it's going to affect other things to start spoiling. So that's just that. So as we are taking care of our I know that I put up to 7 now. I don't know why the system logged me out. Maybe even Zoom is tired. They say we should round up. Maybe Zoom say I'm talking too much. Let me share. I think we're almost done.
That should be network, man.
Yeah. You know it rained heavily today, so it's expected. Okay. So I think I have to be on a faster lane so we can be done. When we are done, we can just go back and make some paparazzi. Let's just finish while we are here. Okay, question. What is the correct name for the compound? I've already told you the correct name. No need of even asking you. So it's paranitro. It can also be called 4-nitro toluene. Remember, whenever you have that line that does not have anything, is regarded as methyl. Is methyl. So that one, methyl and benzene, gives you toluene. And at carbon number 4, I have nitro. So either I call it 4-nitro toluene, I'll call it paronitro toluene. So this is another one. When you go through it, you'll understand it because the answer is there. So those two are the methyl. Because I have 2 methyl, I cannot talk about toluene again. Okay. Okay, let's talk about the reactions. I think that's where we're going to end here. The reactions, I said the reaction is electrophilic aromatic substitution reaction. These 3 words are very important. Okay, in that case, I replace hydrogen with an electrophile. And this electrophile cannot come easily without a catalyst. Okay, so examples of electrophilic reactions, we have halogenation. In halogenation, we use X2. That's all halogens must come as a molecule. So X2 can be Cl2, can be Br2. These two are mostly used, but they can be iodo, but it's rarely used. And fluoro is rarely used too. Now, in that case, if I want to do bromination, I will write Br2 and FeBr3. So if you make sure you are conversant with the catalyst is X3, while the halogen is X2. So another reaction we can do is nitration. In nitration of benzene, please correct it. In nitration of benzene, I need conc nitric acid and conc sulfuric acid. Please, that's the sense of the class. Don't just go and use normal nitric acid and sulfuric, you failed it. Because benzene does not have any compound that can activate it. But if I want to nitrate phenol, I don't need conc. I'll use just nitric acid and sulfuric acid. But when I want to nitrate benzene, I need conc nitrate and conc sulfuric. Please take notes. Because in the exam hall, I might choose not to bring benzene, I can bring phenol. And I'll be expecting you to give me not conc. So whenever I'm dealing with benzene, I need conc. When I'm dealing with phenol, I don't need conc. Why? Because the hydroxy group in phenol is activators. Activators are compounds that make reaction to occur faster. So they are like, when you have money, when there is money in your account, you are highly activated. So that's why even when you go to a shop, you don't need to check your the price. But when you don't have any money in your account, whenever you're going to go and shop, you have to go and confirm the price before you put it in a basket because you're not very activated. So an activator can hasten to reaction. It does not need a catalyst. Okay, does not need any strong thing. It's already ready to react. But when there is no activators, you have to put conc, especially in nitration reaction. Okay, sulfonation. Sulfonation, we are using sulfonic acid. Okay, in conc sulfuric acid. That must be conc, please. And then another one is Friedecraft. There are 2 types of Friedecraft reactions. You have to understand it very well, especially people that are doing PhD. Two types of Friedel-Crafts reaction are alkylation and acylation. In acylation, we are going to form a ketone. In alkylation, we are going to form alkylbenzene. So normally at your level, nobody can give you anything lower than methyl bromomethane, okay, as my methylating agent. Methyl, okay. So that you can, because if you want to start using ethyl and propyl, there's a problem of rearrangement, which is beyond the scope of this class, because what you are doing is just foundation to brush your memory about chemistry. So Friedel-Crafts need Lewis acid called aluminum trichloride. In alkylation, I'm using chloroalkyl or chloroalkane. The simplest one you can use is chloromethane. Then in my acylation, I'm using acyl halide. Now, remember the difference between them is RO. In acylation, difference between them is RO, because alkylation is RCl. So the CO in acylation is what made difference between alkylation and acylation. So in my acylation, I'm going to form a ketone. Look at the rearrangement of acylation. In acylation, the bonding is connecting to carbon. But while in alkylation, you simply attach the methyl, just like forming a toluene. If you use the methyl, it's going to form a toluene. But in terms of acylation, my connecting point is carbon that bears the carbonyl. So the carbon that bears the CO is the connecting point, while the alkyl is attached. Don't worry, I'm going to endure. There are people that are temptation, but I'm prepared to endure. I've said to forgive them in advance, because if I become angry with them, they're going to fail this course. I don't want them to fail course. And my co-host, my co-host is not active. My co-host is not active. How can I make this person co-host? Am I?
No, ma, I'm trying to mute them and it's not going. I'm trying to mute them and I didn't see the mute symbol. I'm active. It's just that
Okay.
I've muted my
Don't worry,
Badmus. I'm just trying to.
no worry,
I don't know
I'm
what.
going to take away. I'm going to take Badmus. Let him go to the waiting room. He's not ready for the class. Thank you. Anyway, that would disturb me, I'm going to remove the person. If he's ready for the waiting room, he would have done the needful. If he's ready for the class, he would have muted himself. But no, this is not the first time he's coming to class. Let him remain there. After you go and listen to the recorded version. So, like I said, when you go, make sure you revise acylation reaction, how to form the product, because some of you will go and write RCO. Remember, whenever you're writing an equation like that, you must consider the valency of carbon, must maintain the valency of 4 of carbon. So that's why carbon is one connect. Remember, in catenation, it's carbon that connects to carbon. So benzene connecting, it has to connect with carbon. Even when you're forming your alkylation, benzene is going to connect with carbon that will connect to hydrogen. Okay, so understand that in the reaction. It should be able to give us at least 3 or 4 of reactions of benzene. So if you don't know it, go and learn it. Detail the reactions of benzene. And whenever you're drawing your benzene should not be dancing. Oh. Your benzene, don't mumble things up. And if you're not good at that, start revise. That's the essence of revision. Start practicing how to draw benzene. Okay, very, very important. This is an example. These typical reactions. Talking about halogenation, where we are using Lewis acid as a catalyst called iron halide, which can be chloride or bromide. The same thing that happens. So we are talking about nitration and sulfonation. They are adding different functional group. In nitration, I'm nitrating, I'm adding NO2. In sulfonation, I'm adding SO3H. Okay, that's how it's going to form benzene sulfonic acid. Why nitration is going to form my nitrobenzene. Some of you make a mistake whenever you're drawing your benzene. You want to form the product, you end up using cyclohexane instead of benzene. When there is no bond, benzene turns to cyclohexane. So these are the things you need to look out for. Now look at Friedel-Crafts alkylation reaction, where I'm going to form alkylated benzene. Okay, now the higher you can see when I'm having my methyl, I don't have issue. But when I'm having ethyl, I can end up having two products. One product. When I'm having my propyl, the higher the number of carbon, there is high tendency of rearrangement or polyalkylation. Okay, so whenever you're told to give an example, go as simple as you can. Nobody is interested in you writing complex and complicating the matter. The essence is for you to understand it. Okay, so this is a Friedel-Crafts alkylation, and we are going to acylation. In acylation, the same thing. Difference is acyl group. Let me pity the person on the waiting room. Oh, he has even gone, meaning that he's not even ready. Okay, in Friedel-Crafts acylation, like I said, we are forming a ketone. What is happening that my carbonyl is going to be connected. So carbon connect to the benzene. Then the carbon is linked to oxygen and alkyl, completing the valency of 4 of carbon. So it forms ketone. Example can be what's different between Friedel-Crafts alkylation and acylation reaction. Okay, the difference is that in alkylation reaction, we are forming alkyl benzene, while in acylation reaction, we are forming a ketone. That's their product. Then in terms of the reaction, in the reactant, in alkylation reaction, I need alkyl benzene. Okay, chloroalkane, or in Friedel-Crafts alkylation, I need alkyl halide. While in my acylation, I need acyl halide. So the difference between them is their reactants and their products. Why I need alkyl halide for alkylation, I need acyl halide for acylation. Why I'm forming alkyl benzene in alkylation, I'm forming a ketone in acylation. So you should be able to know, especially those doing PhD, you should be able to know difference between Friedel-Crafts reactions of Friedel-Crafts. You should know types of Friedel-Crafts reactions, and okay, with the example and their differences. I don't know how the question will come, but just know this. So let's ask our question. We've come to the end of the class. Ask your question. Ask your question so far that we've done from the beginning to the end of today. What are the things you feel you need more light? What are the things you feel you did not understand well? So we can trash it now. So there's no question, right? Okay. Okay. Eat boiled corn. Yeah, boiled corn is better than roasted corn. Except you want to roast your corn with your oven. The problem is the polyaromatic hydrocarbon. Is that open fire that has with smokes. That's the problem. If you not watch my video on your blood type diet, and if you're on the big side and your blood type O, please, corn is not your meal. Blood type O, corn is not your food. Blood type B, corn is not your meal. So if you like corn, eat with caution, because corn is going to cause you to gain negative weight and can predispose you to diabetes. So apply with caution. Apply caution when you're taking your corn. So ask your question. Popo Olaoluwa Kemi. The floor is open for you.
Yes, ma. Is it better to roast our plantain or corn with air fryer than
Yes,
to use the
yes,
coal?
yes. The problem is that charcoal and the smoke. So anything you can do to prevent it is better. Air fryer is even healthier than your normal frying. Luakemi, are you buying air fryer for me?
Maybe one of these days I'll do that, ma.
You're a politician. You don't play politics like this.
I'm not a politician, I'm a teacher.
Okay, you're a diplomat. Okay, no wala.
Yes, maybe.
Okay.
I'm trying to keep all the friends.
Okay. So any other question? See, as much as it depends on you, as much as it depends on you, it's better to cook your food than roasting it on open flame. Okay, and it's better to cook
All
use
right.
your yes, it's better for you to use your air fryer than you using
Hello,
oil
ma.
to fry your fish. I can hear
Hello,
I
ma.
you.
have a question, man.
Okay. Who let's allow one person at a time. Who is talking? Is it Odina or
Giwa.
Abba? Okay, Giwa. All right.
Yes, ma. Um, in order to prevent smoke, what if you make use of a foil paper to wrap it?
My dear, that foil paper is even the worst. I beg, run away from foil. I beg. That's aluminium.
Aluminium.
That's even the worst. You see, I see them now where they use fish. They use foil paper to wrap and do fish. I
No, me,
beg.
I don't really
All
like
those,
smoke food. I don't like smoke
all, all those paparazzi, they are even contaminating the food more. Just like using your aluminum foil to cook moi moi. Better go and use away, the Nigerian away. Go and buy away and use it and it's natural. And the essential oil from the leaf will enter into your moi moi and you're enjoying it. And all these people, they will go and bring one thing, they say use it to cook your moi moi. Go and use it away and cook your moi moi. Or even away is the healthiest thing you can use for your moi moi. That leaf they use for moi moi is the healthiest. Whether you're using your plate, away still stands out in health. The worst one you can do to yourself is go and use nylon to cook moi moi. That one you're killing yourself gradually. You're using plastic plate to cook moi moi, and you see somebody selling it and you're buying. Please be careful. Okay.
no pen, ma.
Hello, ma.
Oh, I
Hello,
can hear
ma.
you. Look, Kemi, you have to
Dangers
take
in
consultation film.
What's the dangers involved in the use of microwave oven to eat our food?
Hey, my dear, the danger is that microwave, especially, they will tell you that they will bring plastic and say this one is a microwave accepted. Those plastic, when you're heating it, that heat of all the rubbish in the plastic enters into your food. So if you must use microwave, use ceramic or something like a breakable. You don't use plastic of any kind, as long as it's plastic, whether they will call it high dense, low dense, and mid dense. Please don't use plastic for that. But if it depends on you, I prefer you don't microwave. The truth is that it's civilization that is killing us. In the time of my fathers, there's nothing like cancer.
Yes.
Even but because now fast food, Indomie, fast food, all this one, fast food,
What about
donuts,
shawarma?
all those ones are rubbish. They are the one that's what is
Shawarma.
killing us. That's what is killing our immune system.
Mm-hmm. Okay.
So if you can, in fact, normally the truth is that the Indians, when I visited them for my research, I realized that Indians don't warm their food. As they are cooking, they are finishing their food now, that time. But it's in Nigeria that we have to. Somebody told me that she cook once in 3 months. You can see how much poison we are eating. You cook it and put it inside freezer. The freezer will block it and block it and block it and turn it into water. You bring it and warm and eat when all the nutrients are dead and gone. So don't make it a habit. But we can't do away with that. But don't make it a habit. Don't cook food that will be inside freeze for 1 month, 2 months. Okay, and normally it's advisable that whenever you put your food in a freezer, when you bring it out, don't put it back inside fridge. It's very wrong. If it's especially for cooked food. No, the best way to do is just pack it in a size that you can pick out and use. There's so many things we are doing that is wrong. Even me talking with you, I'm trying to readjust so many things. There's so many things we are doing that is wrong. So, but when you have that consciousness, it is better than not knowing. That consciousness will make you to apply caution in some things you're doing. Know that I must not do this. But if you don't know, uncle, you can abuse it, and tomorrow we'll start looking for village people. While we are the village people ourselves, that cause our problem. Odedina, Odiana, Vera.
Okay, ma. My question is, in this Friedel-Crafts acylation, you wrote
Yeah.
acid chloride reacts with benzene. Is it actually acid chloride?
What is an acid chloride? Is an acid chloride. See, if you RuCOOH is an acid, right? Are you with
Yes.
me?
Yes,
It's an
ma'am.
acid.
Yes, ma.
Then
Is that
the
carboxylate?
hydroxy group,
Is that carboxylate?
the hydroxy group has been replaced with chlorine.
Okay.
So making
Okay.
it an acid chloride. It's an acid chloride. Acid has been it's an acid chloride. And in terms of
Okay, ma.
reaction, that if you watch my video on Dr. Anita chemistry, and you watch on reactions of carboxylic acid, you can understand that when I have my acid chloride, it is more reactive than normal carboxylic acid. So if I have ethanoic acid, well, that is CH3COOH, and I have CH3COCl. COCl is more reactive than COOH because of the chlorine is highly electronegative than hydroxy. So that's a high level of chemistry I don't want us to enter into.
Please, ma.
Okay, ma. Must it be concentrated?
No, there's nothing like concentrated. In terms of the craft reaction, you're not using any concentrated.
Please, ma.
Do you understand? We're
You
not
made
talking about
mention of
concentrated in Friede craft. Just
Okay,
no. The way we're talking about concentrated is in nitration and sulfonation. So wherever there is need for concentrated, I'm going to talk about it. So anyway, I did not talk about concentrated. I did not stress on concentrated. Please don't put concentrated, please.
Okay, ma. What's the function of the aluminum chloride?
Is a Lewis acid. What does acid do? Acid catalyzes the reaction, and at the end of the reaction is being regenerated. It's like a push. It's pushing the reaction to occur. Now, it is aluminum chloride that is going to help us to release that aluminum chloride is going to take the chlorine from your reactant, so as we can have an electrophile that will do the reaction. At the end of that reaction, it's going to release that chlorine to the hydrogen we remove from benzene to form HCl, and itself is going to be regenerated.
Okay, ma. Thank you, ma.
Welcome. Okay, Sani.
Okay, well, good evening, ma.
Good evening.
Maiden, thank you very much, ma, for the lecture, ma. We really appreciate it, ma.
Welcome. Welcome.
Yes, I want to ask a question concerning the use of air fryer, ma. So there are some air fryer that has silicone lining, and there are some that has paper lining. I want to ask which one is more safer, and also the use of these silicone spoons and pots. How is it to like weight-wise?
The truth is that silicon does not react. Does silicon react? Now, let me tell you, as a chemist, whenever you're looking at those things, don't talk about the reactivity. Does silicon react? If silicon does not react, silicon is fine. So, whenever you want to look at the health benefit of something, whatever we are talking about, what we're talking about aluminum pot not being very good is because of leaching. The aluminum pot is going to leach inside your food. Now, that's metal poisoning. And when we are talking about some of these silicone spoon, and remember, if you have any pan that has silicone lining, and whenever there is a scratch, that one become poisonous again. This life, now God go save us soon. Whenever there is a scratch, there's interruption already. That one is another problem entirely. And that's why, see, if you look at all these pots that you buy from this Tokumbo pot that you buy, some of them are not just because they are bad that you go discard them, because there is a scratch of the lining. That lining has been scratched. To Oyibo, it is poisonous. They don't need it. But to us, we feel that this pot is still very new. We buy it. But Oyibo, there's something they saw and rejected it. So that's another thing. The pros and cons. Some of all these things have their pros and cons, but the problem is that the one of aluminum has more con than pros, if there's any pro at all. So check if silicon does not react. So silicon is safe. But when your silicon starts,
clay pots.
Yeah, my dear, that if you can, I'm looking for one, seriously. That is the healthiest, even in drinking water. I was reading an article and they are telling us that when you're drinking your water from water bottle, some of us, we abuse water bottle that you put water and drink it and remain the next day you top up. Research has validated that whenever you're drinking water, and remember you're bringing down, and there's some that will go back into the container, right, from your mouth, right? Those ones that are bacteria in your mouth that you have put inside the water, and this bacteria can breed in seconds. So when you take that water bottle the next day without washing it, you're contaminating your system. So, and they also advise that is not the best way to drink water is not because when you're drinking it from plastic, you're drinking plasticizers unknown to you. So that the best way to drink your water is using your stainless stuff. And don't ever drink and remain. The next day, discard that water and wash and use. But if I can see a clay cup, a clay whatever, water bottle, if anybody have an idea on how to make one, it's a good business. So I will buy into it. A clay
How
pot,
about
I will buy
mug?
into
I
it.
think a mug is okay. Mug.
Yes, mug is fine. Mug is fine, but you know that some of us are people that normally go out with water. You know that there is this one water bottle that came out, right? That they put straw into.
Stanley cup.
That one is another thing, no? Because some people can use that Stanley cup for a week without washing it. Some of these things we are doing is civilization that is making us lazy. Whenever you're using stuffs like that, even that straw you're using, Inko, do you wash it? Me, if I want to buy anything, I don't buy the one that has straw. It's better for me to drink my water normally. So if I want to wash, I'll be able to have access to wash all the nook and cranny of whatever I'm using. Prevention. We do our part as human and leave the rest for God. But we cannot be perfect. But at least the one you imply it so as to save humanity. Thank you very much. Any other question? No question. So
Good
if
evening,
you've not
ma.
come, good evening.
Sorry, ma. Good evening, ma. Yes,
You're
ma.
just waking up. Welcome.
Thank you, ma. Ma, sorry, this is not a question. It's more like a reminder of the message I sent in the platform.
Okay. For the assignment, Abby.
Yes, ma'am.
I'll check it. I will check it and revert. All right. Okay. So
Yes, ma'am.
if you've not connected to my YouTube channels, I want to oblige you to connect. Some things that it's just like blood type O. If you're still eating apple and your blood type O, please stop. Not every fruit is good for you. So understand what you need to eliminate from your fruits. Not every vegetable is good for you. Blood type O, you're not meant to eat cabbage. So watch and understand. So you know how to eliminate and what to eat more. Okay, cucumber is not good for blood type O's. The cucumber is very good for blood type A's. So watch, ask Dr. Anita, and improve your lifestyle. Okay, so if you have any other question that as regarding the class, and if you watch the video and have any question, you can ask question on that YouTube. I'm going to respond to you. So just know that when you're reading your chemistry and you realize that something you don't really understand, you can private chat me and ask me the question. Okay, the essence is that for you to understand chemistry, not to cram chemistry, to enter exam hall and write chemistry without struggle. You can also listen to the recorded version on YouTube. Everything is there. Okay. Remember, if you have B, I'll manage it. But if you have C, you're not my friend. So I wish you the best. I'm going to share general revision question with you on Google Classroom. Okay, so you can solve it and prepare for the exam. And there'll be a time. I'm going to make out time for us to have tests, so that people that does not have access to Google Classroom will have to look for another method of doing this test, so that everybody will be assessed at the same level.
That will be very nice. You.
All right. All right. Okay.
Oh,
Thank you very much. Bye for
thank
now.
you. I will. Bye-bye.
Thank you so much, ma'am.
Bye. Thank you.
Bye. Stay blessed.
Bye.
Bye.
Bless you too.